All right. Assalamualaikum. A very good day. This is e-lecture series for JIM 212 statistical method. And in this e-lecture, I will discuss the third chapter, analysis of variance. We will focus on the one-way ANOVA. Okay. All right. First thing first, you have to know what is one-way analysis of variance or ANOVA. Okay, we use ANOVA to test a hypothesis concerning the mean of three or more population. Okay, if you still remember what you have learned in JIM 106, if you want to compare the mean between two groups, we will use the t-test. Okay, but now we use analysis of variance if we want to test or we want to compare, okay, mean of three or more population. Okay, and for analysis of variance, f-test is used, and with f-test all the means are compared simultaneously and more efficient compared to t-test. If we want to compare more than two means, the meaning of this statement is if you want to compare the mean between three groups using the t-test, you have to compare the first group with the second group first. Then you have to compare the first group and the third group. And the last one, you have to compare the second group and the third group. Meaning that you have to do three analysis of t-test, but if you use analysis of variance, you just have to do one analysis. That's why stated here that analysis of variance are more efficient. Okay, it's more efficient compared to t-test. Okay, even though one is comparing three or more means, in this use of the f-test, variance are used in the test instead of means. Okay, that is the reason why we call this analysis of variance. Okay, so this is the assumption for the f-test for comparing three or more means. The first one, the population from which the samples were obtained must be normally or approximately normally distributed. The samples must be independent of one another, and the variance of population must be equal. So this is the assumption before we proceed to the analysis. And this is the hypothesis for ANOVA, H naught, mu1 is equal to mu2 until mu n. It depends on the number of group that you want to compare. Okay, mu is the mean for population, and H1 alternative hypothesis, at least one mean is different from the others. And this is how to find the degree of freedom. We have two degrees of freedoms here, one for numerator and another one for denominator. So DFN is a degree of freedom for numerator, and DFD is a degree of freedom for a denominator. And the degree of freedom for numerator is k minus 1, where k is the number of groups, and the degree of freedom for denominator is n minus k, where n is the sum of the sample sizes of the groups. And the sample size need to be equal, and the f-test to compare means is always right tail. Okay, this is skewed to the right. Okay, f distribution is skewed to the right. Okay, this is the analysis of variance summary table. So this is not compulsory, but I suggest my student to summarize all the information in the table before proceed to the decision and also conclusion. So what we need in the summary table is the first one is a source between group within group, and the total. And then the second column is sum of squares, SSB, SSW, and SST. SSB is sum of squares between group. SSW is sum of squares within group, and SST is a sum of squares for total. And the next column is degree of freedom. Degree of freedom between group is k minus 1. This is for numerator. Degree of freedom for denominator or within group is n minus k, and total degree of freedom is n minus 1. And then we need another one column for mean square. So to find mean square between group, you just have to divide SSB divide by k minus 1. So how to get the value here? MSB actually is equal to SSB divide by degree of freedom, k minus 1. Okay. For MSW, so this is actually SSW divide by n minus k. And to find F, statistic, okay, so this is our test statistic. So this is equal to F is equal to MSB divide by MSW. So this is F. Okay, after we calculate the test statistic F, then we just have to compare with the critical value from the table to make the decision and also the conclusion for this analysis. Okay, this is the steps. Okay, so this is the steps for analysis of variance. Okay, the first step, you have to state the hypothesis. Actually, if you still remember, in this course, every test, hypothesis testing, include these 5 steps. The first one, you have to state the hypothesis. The second step, you have to find the critical value. To find the critical value, the information that you need is K and N. K is the number of group, and N is the total number of sample. Step 3 is compute the test value, test statistics. So to compute the test value, you have to find the mean for each group. Okay, then you have to find the grand mean, meaning that this is the mean for all. Okay, not for each group. And the third step is you have to find SST, SSW, and SSB by using this formula. So SST is equal to the sum of x minus x double bar square, where x double bar is the grand mean. Okay, x double bar is a grand mean. Then you have to find SSW. SSW is equal to the sum of x minus x bar I. X bar I is a mean for each group. Okay, so x bar 1 is the mean for the first group, x bar 2 is the mean for the second group, and so on. And SSB is equal to the sum of Ni multiplied by x bar I minus x double bar squared. Okay, x double bar is the grand mean, and x bar I is the mean for each group. Okay, Ni, okay, small n here, is the number of sample for each group. Okay, then after you compute the test statistic, okay, the test value, and complete the analysis of variance summary table, then you can make the decision. Okay, to make the decision, as usual, you just have to compare the test statistic value and the critical value. If the test statistic value is in the critical region, meaning that we can reject H naught. And then we proceed to the last step. You have to summarize the result. Okay, after make the decision, then we have to summarize the results. Okay, so this is an example how to proceed with analysis of variance analysis. A researcher wishes to try 3 different techniques to lower the blood pressure of individual diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group takes medication, the second group exercises, and the third group follows a special diet. Okay, after 4 weeks, the reduction of each person's blood pressure is recorded at 5% significant level. Tests they claim that there is no difference among the means. Okay, so after 4 weeks, so this is the data. The data represent the reduction. Okay, the reduction of blood pressure if the sample using a medication, exercise, or diet. Now we have to compare. Okay, the question now at 5% significance level, test the claim that there is no difference among the means, meaning that we have to compare the mean for the first group, the second group, and the third group if there's any significant difference, okay, for any groups. Okay, we want to compare the mean, then we proceed with analysis of variance. Okay, so how to do the analysis of variance? The first step, okay, the first step you have to state the hypothesis. Okay, this is the first step. State the hypothesis. Now hypothesis H naught mu for the first group. Okay, mean for the first group is equal to the mean for the second group is equal to the mean for the third group, meaning that there are no difference of mean, okay, no significant difference of mean between these three groups. And H1, the alternative hypothesis, at least one mean is different from others. Okay, so at least one mean is different from others, at least one, maybe two. Okay, then we proceed to the second step. You have to find the critical value. Okay, to find the critical value. Okay, to find the critical value, the information that you need is k minus 1 and n minus k. Since we have two degree of freedom, the first one is numerator, for numerator, and the second one for denominator. Okay, now you can calculate the number of sample for each group. Okay, the number of sample for the first group is 5. There are 5 samples. For the second group is also 5, and the third group is also 5. And N, capital N, is the total number of sample, meaning that N1 plus N2 plus N3. So this is equal to 15. Okay, so this is the first step. Then next you have to calculate calculate or find the degree of freedom for numerator. Okay, so degree of freedom for numerator is equal to k minus 1, where k is the number of groups. Okay, now we have 3 groups. Okay, the first group is medication, the second group is exercise, and the third group is diet. So k is 3 minus 1, so this is equal to 2. So this is the degree of freedom for numerator. And next, you have to find the degree of freedom for denominator. So the degree of freedom for denominator is capital N minus K. So the capital N is the total number of sample, N1 plus N2 and plus N3. So this is equal to 15 minus K. K is equal to 3. So this is equal to 12. Okay, now you have to refer to the F distribution table. Okay, so you just have to find the value of the critical value by referring to the row and also the column. Okay, for row and column, for the row is degree of freedom for numerator. Okay, the first row, and then the first column is degree of freedom for denominator. So you have to find F to 12. So this is equal to 3.89. Okay, 3.89. Okay, now we can find the test statistics value. The first step, we need to calculate the mean for each group and also the total mean, or sorry, the grand mean. Okay, the mean for each group is x bar 1. So this is equal to 10 plus 12 plus 9 plus 15 plus 13. Then divide by 5. Okay, so this is equal to 11 for 11.8. For the second group, 6 plus 8 plus 3 plus 0 plus 2. Then divide by 5. So this is x bar 2. This is equal to 3.8. And for the last group, this is 5 plus 9 plus 12 plus 8 plus 4. So this is x bar 3. So this is equal to 7.6. And then to find x double bar grand mean, you just have to total up all the values, okay, which is 10 plus 12 plus 9. Okay, after complete the first group, then you proceed to the second group, 6 plus 8 plus 3 plus dot dot dot, and the last group until 8 plus 4, and all these you divide by 15. Okay, total number of sample. So the grand mean is equal to 7.73. Okay, so after you determine the grand mean, now we can proceed to find SST, SSW, and also SSB. Okay, SST. So the formula is the sum of x minus x double bar square. Okay, so this is equal to, this is total, SST, nama pun total. Meaning that you have to consider all the data here, okay, from 10, then 12, 9, then proceed to the second group until the last data is 4. So this is equal to 10 minus 7.73 square plus, okay, for the second data is 12 minus 7.73 square plus, okay, until the last data is here, okay, plus 4 minus 7.73 square. Then you just have to simplify this. So SST here is equal to 264.93. Okay, so this is SST. Okay, next we calculate the SSB or SSW, either one. Okay. Okay. Now let's say I try to find SSW. Okay, SSW is the sum of x minus x bar I square. Okay, so for the first group, x bar 1 is equal, this is what we calculate just now, x bar 1 is equal to 11.8, x bar 2 is equal to 3.8, and x bar 3 is equal to 7.6. So this is equal to, now we consider the first group. The first group, for the first data is 10 minus 11.8. Okay, 10 minus x bar 1. Okay, since 10 is the first sample in the first group. Okay, this is square plus, so the second data is 12, then minus x bar 1. Okay, it's still in the first group. Then the next data is 9 minus 11.8 square. Okay, then this is 15 minus 11.8 square. And the last data for the first group is 13 minus 11.8 square. Okay, after you complete for the first group, you proceed to the second group. Okay, for the second group, this is the first data is 12. Sorry, the first data is 6. 6 minus 3.8 square. Then the second data is 8 minus 3.8 square. Next is 3 minus 3.8 square. Next is 0 minus 3.8 square. And the last data for the second group is 2 minus 3.8 square. And then for the last set of data, the first is 5. So this is 5 minus 7.6 square. So you use the mean for the third group. Okay. For the data in the second group, you use the mean for the second group. For the data in the first group, you use the mean for the first group. Okay, now the mean for the third group is 7.6 plus, next is 9 minus 7.6 square. Then this is 12 minus 7.6 square plus 8 minus 7.6 square. And the last one is 4 minus 7.6 square. So you just have to total this, okay? So this is SSW, and the total for this is 104.8. And the last one, you have to find the SSB. Okay, SSB. Okay, so this is the mean for the first group. We still need this information. Mean for the first group is 11.8. The mean for the second group is 3.8, and the mean for the third group is equal to 7.6, and the grand mean is 7.73. We need all this information to find SSB. Okay, so SSB, sum of square between group, is the sum of NI x bar I minus x double bar square. Okay, so Ni, the small n, is the number of sample for each group. So for the first group, okay, this is equal to, for the first group, N1. So the total number of sample in the first group is 5. So this is 5. X bar 1 is 11.8 minus x double bar is 7.73. So this is for the first group. Now we proceed to the second group. Second group, the number of sample in the second group is 5. So x bar 2 is 3.8 minus x double bar is 7.73. And for the last group, the number of sample is 5. So this is 3.8. Sorry, this is not 3.8. This is 7.6 minus 7.73. So this is square. So now you just have to calculate this, simplify, and the answer is 160.13. Now we complete the basic calculation. Now you just have to transfer all the information, all the values that you have determined here to the table of summary. Okay, table of summary for the ANOVA. Okay, by the way, before that, okay, you have to know the relation between SST, SSB, and SSW. Actually, you just have to calculate either two of this value. Okay, either SSB and SST only, or SST and SSW only, or SSB and SSW only. Because the relation between these three sum of square is sum of square for total is equal to SSB plus SSW. Okay, meaning that if you calculate SST and SSW, then automatically you can find the SSB without using the formula. Okay, for this example, SST we calculate just now is 264.93. Okay, 93. So let's say we want to find SSB, and SSW we calculate is 104.8. So SSB is equal to 264.93 minus 104.8. Okay, so yang ini kita akan dapat SSB. Okay, so tolak ini kita akan dapat SSB. So SSB is equal to 160.13. Sama aja, dapat ni balik. Okay, so maknanya tak payahlah kira tiga-tiga sekali. You just have to choose any two. Okay, calculate any two. Okay, now you just have to transfer all this in the summary table. Okay, the summary table, we need sources. Okay, the first one is source. The second one is sum of square. The third column is degree of freedom. Next is mean square. And the last one is F value. Okay, so the first one is between group. The second one is within group. And the last one is total. Okay, SSB. Okay, SSB is 160.13. You just have to transfer, okay, the value from the previous calculation. SSW is 104.8 and SST is 264.93. The degree of freedom for between group is 2. Okay, 2 is K minus 1. K minus 1 is 2. And degree of freedom within group is N minus K, capital N minus K. So this is equal to 12. And MS is this value divided by 2. So this is 80.07. And MSW is this value divided by 12. So this is 8.73. Okay, so to find F is this value divided by this. So this is 80.07 divided by 8.73. So this is equal to 9.17. Okay, so this is our test statistics. Okay, now you just have to compare with the critical value. So this is the curve, okay, skewed to the right. The critical value is 3.89, and this is the critical region. Now you can only reject H0 if the test statistic value is in the critical region. So the test statistic value is 9.17, which is in the critical region, meaning that our decision is reject H0. Okay, once you reject H0, you have to make the conclusion. So the conclusion is there is enough evidence to reject the claim okay. So what is the claim? The claim is once you to reject the claim is there's no significant difference. Once you reject the claim, meaning that you can conclude that at least one mean is different from the others. Okay, then complete. Okay, then complete. So this is how to do the ANOVA, analysis of variance, manually. So just follow the 5 steps for hypothesis testing. Okay, so I think that's all for this e-lecture session for one-way analysis of variance. Okay, thank you very much.